Okay, audio check. All right, that sounds okay to me. If anybody doesn't like it, they can complain if they want, and that would be fine. Welcome to the Discourage of Hesitancy. Today is compiler day. We're going to work on our Tokenizer Generator. And we will be on the Tokenizer Generator for a while. Let's see. So my Emacs has my journal from my other project, the main project we've been working on. So I think what I need to do is I'm going to kill Emacs and restart so we don't have a bunch of those files open. Okay, so let's bring that back up and see if it's, there it is. All right, so size everything for streaming and active projects VV. And let's go to our doc, in our to do. And our journal. Okay. So in both Word Sleuth, our game engineless game, and in our compiler, we've started documenting things like lines of code. I don't actually like lines of code. An alternative we may explore is called churn. So I'm just curious if I can figure out a git command for git if 2 commits only show lines added, removed, modified. Is that just git diff numstat? So basically we're looking for a number of lines changed, which is more of a... Okay, so I'm just curious here. We don't have, let's see here, let's get a shell up. It's just me musing about something. I don't think we have too many people in the chat yet anyway, so it's time to explore. Git status, git log dash, and I think we have 2 commits, initial commit and that one. So if we do git diff dash dash numstat between our 2 commits, and it needs to be this. I need a dot dot. It's telling me that's not dash dash numstat. Dash dash stat. It's better. Insertions, deletions. I guess the make file got cleaned up. The main file got cleaned up. Okay, interesting. I wonder if this would be a more useful metric than just lines of code. Because this last week, I've been looking just at volume of code, so lines of code raw measure. So if we go into source word count dash lines star.hpp star.cpp, and that's the total number of lines in every file. So really, a better measure would be called churn, which is, and we could look at net churn, or we could look at positive and negative churn. So when we do a big cleanup and we simplify things, we would get a lot of deletions, which would mean that the code is changing a lot, but in a downward sense. Most of the time when you add a new feature, this is the one that goes up, insertions, deletions. I wonder if we can write a script to check out commit A, do the word counts, and we may filter out some different files, like our sandbox file in the other project. Do this diff, remove those files that we don't care about here, and tally up those lines of code. I mean, we can. That's certainly an option. So that is an idea. Where is there? Is there? And I don't mind doing that until people show up to watch or are interested in actually doing the compiler work. Let's add a note. To do. Notional ideas. Measure churn instead of lines of code, or in addition to, in addition to lines of code. Okay. This would be check out old commit hash. Hit check out a word count dash L in source directory minus star.hpp star.cpp in source minus exclusions, which for us would be something like word count dash L star warehouse.hpp star warehouse.cpp, and the other one was sandbox.hpp sandbox.cpp. Lines of code, old hash. So basically, we're looking at a percentage change, not a volume change. This is the second thing would be this is why I think we would need to exclude certain files. Process output of A, B. I don't think that the ... has to be there. Same output, so it's fine. We'll put the commands we care about in here. Those will be useful. This will probably be a Python script. Process output of get diff stat AB. Oh, interesting. "19 lines removed of 14 lines. 2/5 were removed." This is not quite as helpful as I would like. Yeah, files that have both insertions and deletions don't help much. Let's see. I'm just... Get diff stat commit. 2 commits by files --numstat. Or alternatively, we process the full diff, and what we look for is this +++ B. This has, let's see. Those are new files. A. Then I have to count the number of dashes, which I don't like. Number of pluses. Do I really have to do it myself? Rename. So we move some files around. Not interesting in terms of this. Minus, plus, plus, minus. These numbers don't mean anything to me. Do they? Or the raw diff. This is the part I don't feel like dealing with right now. Additive churn equals lines added over lines of code. Subtractive churn lines removed over lines of code. We can measure the total churn, which could equal additive churn plus subtractive churn, which should be equal to additive churn less subtractive churn all over lines of code. Getting a report like that with regard to some of our projects might be very informative. I would have to look up each weekly report I've been generating. So this thing, this last week we generated 125 lines per hour. It was kind of a short stream, and it was mostly talking. And we got to copy paste like our basic log file and some file reading stuff that we just copied from somewhere. So that's a short stream with artificial inflation of lines of code. This is an idea to experiment with in the future. I don't feel like dealing with it today. So today, we need to read, well, let's line up our to-dos. We are going to read a project file. This will be bootstrapping just sscanf. We need to read the Tokenizer definition file. Again, this is not the for realsies. We're going to generate some output. Probably common things like file, character reference. We'll talk about those in a minute. String reference. We'll see how far that gets us. That's with dependencies or down the road. So we will want to read eventually our project file, replace bootstrapped version with our own generated tokenizer and generated parser. And the same thing with the tokenizer definition file. Okay, so we're gonna fast and dirty these two on purpose. Later on, when we've got a lot of code written and it's generating useful code finally, we will be replacing, you know what? Replace bootstrapped read of project file. We're going to make this into 2 subtasks because we can do them as separate tasks. Generated tokenizer, same thing with the parser. So what's going to happen is we're going to end up in a state where our tokenizer generator and our parser generator are going to output code, which we then put into our own tokenizer generator, parser generator as part of itself. So it's going to be a nice little recursive, self-referential thing. The first thing that's going to get done is the tokenizer. Then we'll update it with a parser after that. Okay. Okay. So I think this, we're going to just start grabbing stuff and putting it in the journal. Today. -0726. Tasks. Okay. This record of what we did. Can go in here. Okay, let's go around here. Okay. Notes. So we're gonna have tasks, notes,
Yes.
it. Okay. Do I have like a design or what do I have in here? Oh, that's it. Okay. Our project file's gonna have to answer us a few questions. Notes. Project file. I need a project name. I need to know supported encodings. I will support ASCII. I will support Latin 1. I'll support UTF-8. No more. ASCII 7-bit characters. That's it. This is a strict subset of UTF-8 and Latin 1. So every character we come to, we have to ask, is this between 0 and 127? So there's a little bit of overhead there. Latin 1 is basically 8-bit ASCII. We don't have to ask any questions. If it's in here, it's 1 byte and that's it. We don't have to ask. So that's going to be the fastest option. UTF support, if you want to do things with Cyrillic alphabet, Japanese alphabets, like katakana, hiragana, if you want to do hieroglyphics, or if you want to do mathematical symbols, kanji, you need UTF-8 support. Now, this is a multiple character size multiple. Each character can have its own byte size between 1 and 4 bytes. So it's more complicated, and to verify a UTF-8 character is fully correct involves some more math. So this will be the slowest option, but honestly, most of your processing time is probably not going to be in the tokenizer anyways. So this is probably not going to be where you need to optimize your compiler anyway. Okay, so we need those. We need to know we need to know more than that. Where? Let me dig up an old core. I kind of started down this path a long time ago. VNV VB dot no. What was it called? VB dot VB. Okay, so we need to know things like class names. I don't want to know about that stuff. We need to know a tokenizer definition. We need to know a parser definition file. Actually, this is an optional. So these are, let's see here. Required. You have to give me a project name and a supported token. And we have to know about the Tokenizer Generator definition. You may choose to define your own parser. So we're not going to require that you actually specify a parser definition. Text mode or encoding. This was an idea I was playing with. I'm not going to worry about that right now. So for now, to consider.
She left.
We may want to generate single file parser wrapping layers. We may want to generate multi-file, multi threaded parsing, single parser, convenience layer. So what do I mean by that? If you know it's only going to be a single file, we can just give you a bunch of implementation details on top. So we could say, literally, give me your file name, and here's your whole tree structure done. Instead of just giving you a tokenizer and generator code, we give you everything that ties those two together and outputs and keeps track of the parse state along the whole thing. So, for example, if you run your tokenizer yourself, then the tokenizer finishes. You have to ask were there errors. If so, we don't move on to the parser stage. When you hit the parser, again, etc., and all those errors have to be accumulated and reported. We can just wrap all that up for you and hide it. And then if you want it to be multi-file, multi-threading, so if you maybe read a build file and it says build these files, then it will actually create a queue of files to build and a thread pool, and it will tokenize and parse each file and hand back control when they're done. So this is one of the big optimizations that's allowed at the tokenizer parser stage. Most tokenizers and parsers are very sequential because of the nature of processing text. You're not going to get huge performance benefits out of most tokenizers and parsers except in multi-threading. Maybe you could be very clever about some vectorization, so using some SIMD instructions, but honestly, I don't see it in a UTF-8 world where that can be very well done at the tokenizer level, maybe even in the parser level. Maybe in the parser. Anyway, the point is, multi-threading is going to be one of the optimizations we can perform at this level. Okay, so since these are the required parameters, that's what we're going to support to start. Okay. So let's close this. We're going to read in project name, coding. What is that? That's in the journal. Oh, what am I saying? We're breaking this down in the journal. There we go. So we open up main. Just take a look at what we've got. Blah, blah, blah. Log level might be something we pass in through argv. As a programmer, you probably want to choose your logging level for, if it's an overnight run, you might want the full details. If you're just running it fast from your desktop, you might not want the details unless you're at the running into issues and you rerun it. Log level set by command line program. For now, we're saying if we're in a debug mill build, just log everything. Process the arguments. Project file name. Let's just get through this. And this was all working at one point. Let's take a look at our make file. What were we doing? We were saying W all, W extra, ST, C++ 17, pedantic. File F, file load. Take a look at our file real quick to remember what was going on there. So we have these if deaths. Was that in the make file? Pretty sure it was. Defines -d file io f open. It would be nice if I could keep track of which file these defines are actually used in. We can have a comment here anyways. That's in the file.hpp. Or we could literally just put the 3 options. We may add a 4th option as well eventually. We may go put in an fmap option, but we are not there yet. Okay. Another thing we might be able to, anyway, we'll get around to it. Okay. I wanted to check one other thing just for fun. If I say load file, does it discard? Yes. Discards all the other stuff. Clear file name. Load. So here's a possibility. What if we don't want it to be a file? What if we're in a UI and we just want to hand a text buffer to the file? That is something I want to do. As we build up this tool set, I want to build a UI around understanding each stage of the compiler tools visualization options. So the UI will have a text box, you'll type in some rules, and then you can click on one, and it will show you how the NFA or the DFA are generated, or what they look like at least. It would be cool to animate it, but that's a lot of work. So maybe we do just want to, and maybe file is the wrong thing. Maybe it's the wrong name. Maybe we just make it text buffer. Oh, and that does raise another question. The question of ownership. If we hand a text buffer, if we had a character array in here, do we only have a reference to it, or do we do a full deep copy of it? I could see both. So let's rethink things a little bit here with regard to our file handling. Oh, no. Oh, yes, yes. Let's rename file and buffer. We're going to call this text buffer.cpp. Text buffer file with text buffer. Yes, yes. Yes, yes, yes. No, 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 no. Yes. Yes, yes, yes. File. File and buffer. Text buffer.c.hpp. So instead of load, it will be read file. void copy text const char star buffer label and const char star text and int size. If you don't specify it, we'll assume it's a null terminated character buffer. Reference text, meaning we don't take control of it. Is that it? Actually, if size is less than 1. Because 0 might be a valid file size or text buffer size. Because you should also test your compiler against the empty string. Is this where we're at? File name. Spell buffer label. Yep. Nope. Yep. Nope. Nope. Yep. Nope. 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 Yep. Nope. 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 Yep. Yep. Nope. 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 Yes. 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 Read file. To do. Compute absolute path from file name. Let's add that to our to-do list. Tech debt. So when we're doing, let's see here in the journal, when we're generating multi-file, multi-threading parsing layers, each file that we parse needs to have the absolute path so that we can determine whether we've already parsed that file or not. If multiple build files reference or include files or however you want to structure your language include something that's already been included, we need to be able to know that. And since paths can be relative, you might get multiple references to the same file that have different relative paths. So we need to translate everything to absolute file paths in text buffer. Okay, so back to text buffer. After we read a file, so copy text means we definitely own this text, and reference text means we do not own it. So underscore contents equals text. Here. That's the first thing we do. And then M underscore size in bytes. So size is always bytes. Equals size. If size is less than 0, underscore size equals string of text. And then up here where we copy the label, do that as well. Except that instead of file name, it is buffer label. There. Same thing here. Compute our size or copy our size here. And contents equals this. And then we copy. So you'll note that this size is the standard C string size where it does not include the null termination character at the end. We will not ever assume, hey, FitWriter, welcome, welcome. How's it going, my friend? We can't really use stir copy. Not bad. Chemistry midterms. Nice, nice. You know your stuff, right? All your acids and salts. Of course, I don't know what level of chem you are, whether it's OChem, PChem. Yeah, there's always a few classes at the end that you're like, you know what, I should have taken this earlier, but like, I don't know about your experience, but my first year was slammed. So there's always something left that you can't get around to until the end. Final semester, you got to take chem. Yep. I assume you're, what, comp sci or something similar? So you're probably taking like an intro level chemistry class. I don't know what your college numbers are at, like 100 level chemistry. Yeah, comp sci. Perfect. So what we're going to do is we're going to do a mem copy instead of a stir copy. Destination source count. Mem copy underscore contents is going to get text, and we're just going to copy this many bytes, and we will never worry about a null termination character in our. Oh, yep, stir copy's fine. So if you reference text, oh, this goes up in copy. This one gets. Okay. So either way, we clear the thing, we set our label, we get our size. Then if we're copying it, we take ownership of that copy. If we're not, then we don't. So we need to add one more field then. Text buffer bool. Oh, do does own contents. Where we set our contents right here. Does own contents equals true. 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 We copy the text, then we definitely own it. If we reference the text, we are not the owners of it. The only place this matters is where we clean up. So where's clean? Clean, clear, clear. If we own, does own contents. Oops. So, if we own the contents, we delete it if we can. We can simplify a bit. If we own the contents and we have actual contents, then we can delete those contents. Just set it. Okay. Too much partying during the first year, huh? So my experience was kind of the opposite of yours. My first 3 years, I was taking 16 to 18 credit hours of every semester. I took a summer course one semester to get the linear algebra I needed for in time for computer graphics. Oh, no parties? That's too bad. Undiagnosed ADHD. Yeah. Yeah, if you don't know that you've got it and how to manage it, that could be a problem. So yeah, I busted my tail the first 3 years, and by the time I hit the fourth year, I could have finished in one semester, except they wouldn't let me take 2 semesters of senior design at the same time. So I took like 6 real credits my second to last semester, and I took a whole bunch of PE classes. Then my last semester, all I had was the one semester of senior design. So my last year was mostly a complete waste of how many credits? I don't remember. It was like 120. Is that right? Let's see here. Let me do math. If I'm doing 16 credits per semester times, they would want you to do 8 semesters. Yeah, it's around 120-ish credits. 120. Yeah. So where are you from? Remember. Yeah, so Canada. Okay, okay. Well, we're probably very similar then. Canada's not that different from the US. Yeah, 120 credit hours, and um, it's kind of expected that you spend about that many hours outside of class on that class, something like that. So yeah, undiagnosed ADHD. That's rough. Did you do internships or something? No, I had a real job all through college, at this little small research and development lab that developed scientific tools. So I became our lead programmer by fact that we didn't have anyone else who was a full time programmer. So by the time I graduated, I had probably a good 3 years of software development experience, and that's mixed with other things. Like I did machining and other stuff too, 3D CAD design, circuit board layout, and manufacture. But yeah, I did not get an internship. I was already earning money. In Canada, do you have a lot of unpaid internships, or are they paid? Yeah, I was lucky. I was lucky to get that job. That definitely smoothed the ride quite a bit. Last change, make file. It is not called file anymore. It is called text buffer, which we can load from a file, or we can set it from external means. Okay, so small refactor. We'll add that to our journal. Oops. We should compile and make sure it runs though. Low efforts. Did I change the font? That is a good question. It does look. Is it too small? I reloaded my Emacs, and sometimes, okay, so when I switch between accounts on this computer, like it changes the screen resolution and it screws things up. So you need the text bigger. You can definitely do that. Hopefully that helps. Ooh, all the flickers. Hopefully nobody has epilepsy. Yeah, let me know if you want the text bigger. We can. That's did not scale very well, did it? 4 months of work for my friend's company. Nice, nice. Another 6 months from something before joining college. Yeah. Yep. I think more people should work while they're in college. There. Is that more readable? That still looks stretched. When I make a change on my screen, it takes a few seconds for it to show up on Twitch, so I kind of have to wait. Oh, I'm going the wrong way. Wrong way. Let's stretch it out this way. Is that better or worse? Now it's wide. Okay. How's that size look? Is that readable? Expected a semicolon. Well, that just makes sense. Need full screen to be readable? If you want to go full screen, let's see here. Here we go. That's full screen. Is that better? All right, all right. Kidding around. So you want it the text bigger. Let's see here. If I remember the. Nope. Nope. All right. Control X equals minus Control X. X Control plus. Okay. Now let's see how that looks. This is perfect. Oh, the player has to be full screen. Okay. Well, now that I've changed everything again, how does this look? One level bigger. Okay. Then off we go. This text is gigantic for me. Okay. What am I looking at here? Bugs. Where are my bugs? Invalid conversion from const void star to void star. So jar temp buffer. What's this? Copy into the temp buffer, that, and then contents equals temp buffer. Okay, so I have a problem in that it only changed the font size. Control 0. Oh, that's even more convenient. Except it's on a per buffer, so I don't think this is actually helpful. I just need to make something like that. Someday I will get this all figured out. Perfect. Main does not include file. File is now text buffer. It's not called load anymore. All right. So let me know if I need to resize anything again. Compilation, nothing in there. I guess we source builds, debug. Okay, it gives me my usage, -p, source main.cpp. There. Okay, so it is reading a file. Perfect. Perfect, right now. Okay, we're gonna stop fiddling with things then. I'm gonna stop guessing at font sizes and changing buffers, and we're just gonna stick with this. Okay. Dum-da-dum. Journal. So this was not an official task, but we refactored file to text buffer. I think getting my bachelor's for the last 7 years, just finished first year. Nice, nice. Bachelor's in what? Computer science? Source of text. Named to text buffer. And added methods for setting text. Renamed text to file to text buffer. Okay. Originally started computer security, then comp sci. I just have zero motivation, no desire to work in the industry. You know, now may not be the right time to join the industry, but if you wait too long, then there's never a good time, right? The right time to join the industry is probably in any time between the mid 50s to maybe the Well, I wouldn't want to join in the 90s. That's when we had the .com bust. And it's been kind of a roller coaster since. So yeah, it's a yeah. I don't know. I don't know what to tell you. I do it because I like the actual software development, the cool projects and things. Like I've got so many project ideas, just can't work on them all. Okay, so we need a sample file. We want test.vv. I want to call it project, but that's not going to work for me. Maybe we just call it vv. Name, encoding, and tokenizer definition. Probably try to get a spot in some FOSS org. Yeah, that could work. I don't know. I hesitate to give anyone advice based on my career trajectory because everyone's career trajectory is so different. Like, somebody will have a friend who gets them a job somewhere, even though they had no education. They'll work that one job for the next 40 years. But like, I got my job right out of college, pretty easy peasy, and worked there for 6 years, and somewhere else for 2 years, then another place for another 4 years. I don't know. It's hard to say. Here's how you get in. Here's how you start, because the industry's changed so much since I started. Tokenizer. We're going to call it test.vv project. There we go. vtoke. So the last couple times I've prototyped this, I've called it Billy and Vey. So the tokenizer generator, I think, was Vey, and the parser generator was Billy. So I'm combining them into one piece of software. I think that that's going to be a better user interface. So I'm calling it Billy and Vey, or VV, but this will be the Billy tokenizer definition and the Vey tokenizer parser definition. Billy and Vey are the brothers of Odin. They helped overthrow the frost giant Jotun. They helped create man. So Odin made mankind out of clay and breathed life into them. Then Vili and Vey granted mankind language and expression. So I thought Vili and Vey were good names for a tokenizer and parser, giving someone language and expression. They did also fight in the wars between the Aesir and the Vanir, and I'm probably mispronouncing all of this, but good old Norse mythology for you. So if you're wondering where the V and the VV come from, Vili and Vey. So is this it? Now let's just get some char star. So this file format is bootstrapping. It's not meant to be robust or good or report errors. At this point, the project file is going to be super hard-coded. So we have project name. project encoding. Do you work with recent CPP standards? I've touched C++20. There was never really a reason for me to switch over, so I'm on C++17, I think, just because I copy paste my old make files. C++23 might have some useful things that I like, but I think C++23 is when format comes in. That might enable me to do some good things, but right now I'm just on C++17. Honestly, I think the biggest changes that really mattered came in C++11. Those were the ones that made a big change. Ugh. There we go. Void. My C++ usage is mostly a mix match of old school C and some C++. Like the good things about C++ after 11 are like lambdas. Functional was a great addition. Um, yeah, mostly it's like C style in a lot of ways. Like I tend to prefer fprintf and old school stuff. Okay. Upset contents. The const char star. Yeah. So let's see here. Let's just take a look. So our tokenizer and parser generator project file. We need name and coding. Okay. And sscanf has the text buffer, then the format. You know what? Let's not make these null. Let's just give ourselves. This is again, doesn't have to be robust. This is our bootstrapping. We're going to load up a project file. It's not going to be pretty. It's not going to be flexible. It's not going to be anything we're going to stick with forever, but we will stick with it for a while. Project name. Coding. project coding. There we go. sscanf. Project tokenizer definition file. Name. Encoding. Name. We're gonna feed those in. Project name. Coding. Tokenizer. Okay. With this much information, we should be able to get rolling. Into project coding. Yeah, sure, we'll take that as an int. Coding. We said we're going to support ASCII. We're going to support Latin 1 and UTF-8. We're eventually going to break these all out into an actual, maybe a struct or a class. But for now, we're just going to stub it all in and make it work. AK Elements is raiding with a party of 3. AK Elements, welcome back. How's it going? Probably ought to give a shout out now that I've learned what a shout out is. Thank you for visiting. I saw your node graph stuff. That's looking pretty good. Ooh, material systems now. See, I keep popping into people's streams to watch their VODs after. It turns out most of you people that I follow started earlier than I do. So I'm like doing chores and taking care of kids. So I got to watch your VODs afterwards. Being useful with the material. Yep. Material systems. So you're going to be doing your basic shaders. Are you doing like a physics-based shader? Yeah, so that's one of the things I really like about like Blender or Unity or whatnot. The shader graph stuff is awesome. Or Unreal. Yep. PBR, good. No, it's really like there are certain problems to which visual graphical programming like shader graphs are just useful. Building up shaders is perfect. It's a lot more intuitive than writing code. Awesome. Real system's going to be a nice complicated one. Now you were doing Vulkan, if I remember right, in your, was it Onyx game engine? Okay. I'm so jealous. I started looking at Vulkan and decided to go with OpenGL to start with. But today is not game day for us. Today is our variety day. We're going to be doing some compilers. We're starting from scratch. Nothing, no libraries, just code we write ourselves in a lovely mix of old school C with a little bit of C++ over the top. And that's where we're at. We're going to write a tokenizer generator. We're going to write a parser generator. And then to tie those together, you have to have a project file. So we're starting by reading the project file, fast and dirty. It's not great. We will later replace the project file parsing with our own tokenizer, generated tokenizer and generated parser. So that's all months and months out. But reading the project file is problem one. So this stuff, it's all going to go into its own class eventually. Let's see how we did. Stray hash mark. I fat-fingered something. That is indeed a pointer. Unused variable text. It's because I forgot to put it in. Well, cool. Thanks for dropping by. I always appreciate the raid. Hopefully you don't find compilers too boring. It's like my guilty pleasure. Like, I've said it all before on the channel. In fact, last time we talked about compilers. A tokenizer, you can just write it by hand and it's not that hard. And we sort of talked about what went into that as like a part of our overview. But I really like the tokenizer part of it, like building up those state machines and making them as efficient as possible, like a guilty pleasure more than a useful piece of code. Protobuf, if you know it. I do not know Protobuf, but yes, I've written plenty of code generators in different environments. Yeah, getting a working proof of concept is always fun. It's kind of where the project turns into a grind. So I've built all the pieces of this multiple times over the years, and I think I'm finally at the point where I know enough to build it all together. So this is me finally moving beyond proof of concept into something I think might be usable. But yeah, there's a million projects I want to build up to the level of proof of concept. So many of them. Not all of them I want to pursue all the way to product. So I understand that. Proj file is not defined, is it? That's very clever of it. Because I didn't type it right. I don't want to run it. Test.vv project. Well, 1 out of... Oh, I bet I know what happened. Never mind, I don't know what happened. That should have worked. I think it should have worked. Oh, I know what's going on. I forgot to increment my offset. Returns the number of bytes read, right? Oh, returns the number of items. Well, that's not as helpful. What? I need to know how many bytes it read, if I can. Format string, etc., etc. Return value, number of items. sscanf. This file's simple. We don't need to overthink this. Let's do it all in one pass. Make sure that the thing equals 3. Nice thing about sscanf is it already takes care of its white space for us, so we don't actually have to worry about how many spaces are in things. I think. Even do something like this, and then the spaces don't matter. Int count equals thing assert. Yeah, so our Tokenizer Generator is going to use a Thomson DFA construction method with a few extra bits and goodies I've invented. Maybe while we're midstream one of these weeks, we'll write a technical paper about what we're doing. But hey, there it all is. Okay, and then we assert if encoding name there means we need C string equals ASCII. So one thing we're going to do also is we're going to allow you to use either ASCII or Latin 1 or UTF-8, depending on how much you care about speed or how much you want to support other alphabets. So that's part of the project setup. Project encoding. Equals ASCII. Latin 1, UTF-8. ASCII, Latin 1, UTF-8. We're going to embed all this into a function or a struct or something, move it outside of this. But for now, we're just stubbing it in. Char star coding names equals as an array. ASCII Latin 1 UTF. insert project encoding is between encoding ASCII and encoding UTF-8. Then when we log, instead of logging the string, we just log the encoding name. It's just a thing I usually do with enumerations. Give myself an easy way to get a string out of it. Compile. Make sure that's still working. Then maybe we move this project definition out into a separate file. Okay, encoding Latin 1. We have a reference to another file. So I was explaining to the other fellows that were in the chat. VV is Vili and Ve. They're the brothers of Odin. When Odin created man by breathing life into clay, Vili and Ve then gave mankind the expression and language. I thought that was good for a tokenizer and parser generator. Vili and Ve. I'm bundling them up together into one project, one executable, instead of like Lex and Yak or Flex and Bison. There'll be one executable for all of it. We need this project file. So first we tell it where to look for the tokenizer definition. Just a moment. Let me see what's going on. Okay, sorry about that. Baby was crying. Nobody was coming to rescue the baby, so. So yeah, Ve and Vili. So Vili is the tokenizer and Ve is the parser generator. So we need to make this file. And I'm going to look at an example like Vili dot, what do they call it? Vili dot Vili tokenizer. This is the format we were using. So keyword is what the token will be called in the code. The actions to take when you get one of these. So when we get a new line character, we discard it. We don't actually keep it inside of our AST. And then we mark the line so the token count can be on the right line number. White space is discarded. Comments are discarded, etc., etc. We put the actions in parentheses. I don't know if I need to do that or want to do that. I mean, for now, we're going to do an even simpler thing just to get started. So maybe we'll just read, oh, because it could be an empty string. I need to think about that for a second. Okay, I think it's time for a restroom break. But I won't be gone long. This will be quick. Okay, we're back. So the problem is it could be empty, and right now discovering that with a very simple parser could be tricky. So maybe we'll put it in parentheses. Okay. Let's make a VB project. It will have pieces of this inside of it. The encoding name we are not going to save. Token definition file name is fine. This will be a public enumeration, num class, encodings. Right, let's char star encoding names. There we go. So now this goes away. Encoding. Encoding. Okay. Initialize our variables real quick. No pointer. Pointer. VB project. Encoding. Error. Just all the defaults, nothing too crazy. If name not equal to null, read it. Okay, there we go. All right. Should probably return a true or false. Let's char star text. I'm going to steal this out of the main function, just right here. We probably shouldn't assert. Count not equal to 3. With logger. Probably should steal some other things out of main, but that's fine. Note, compilers today. Yes, doing compilers. Parse. Result equals false. Else. I have a problem whenever I put one bracket in, I can't just leave just the one bracket. F8. Got the project encoding name. Token definition, file name. Pass every assertion, pass everything. Result equals false. If result. So if we have passed, then m underscore name equals name underscore coding equals project coding underscore token definition file equals token definition file name return result. We need a function for clear, I think. It's basically just gonna dump everything we have. We load a new file. So both these lines will go in there. We go to parse something, we clear it. So we can load multiple projects within the same object, do things with them, and move on if we want. Now we can set some values. There we go. So yeah, if anybody has any questions, this is all pretty early days, building up the top level down. Kind of talked about that last time. The last few times I've built pieces and bits of this, what will become this project. I built them from the bottom up. I wanted to know how this works, and then I built on top of that, and on top of that. Once you've done that a couple of times, you kind of understand what the system has to do, and then you can do the top-down design where you say, what does the user see? How does the user interact with it? So we're actually building the top level where the user sees things, and then we'll get deeper and deeper as we go. Instead of what I usually do is I really like exploring from the bottom up. Build a teeny tiny piece that works, add on it, add on it, add on it. This one is user first, then we'll work our way down to actual functionality. It's a little different from my usual. And maybe I should expand, maybe I should put a concerted effort into documenting what that design is. Maybe that's something that would be of value to people, because right now it's in my head by virtue of the fact that I've built it so many times, or built the pieces of it so many times. Okay, let's see, assert MC string in our 3D proj. This all goes away. Oh. This whole function goes away. Instead, we do this vv project proj dot xbuffer dot contents. Can I? Is there any? That kind of presupposes a no, maybe. Okay, well, the fact that we're using very, very bad project file parsing. So here's the problem. I'm very careful in text buffer in several locations to not preserve a null byte at the end of the string. So let's see here, let's go to scratch. A string in the C strings are an array of characters, and it can be some length, doesn't matter. So when you write this, it's a shorthand for this. An array of this, followed by a special character called the null termination character. This is a C string, an array of characters with one character at the end being the null termination character, the end of string character. \0. And what usually happens is you then have to find out the length of your string. Most of the time you don't know. So you actually count forward however many characters until you hit the null termination string. So when I'm using sscanf, this is actually reliant on that null termination character being in there. With the way I read files, it doesn't. So it's very likely that if I will have to replace this eventually with something much better, but we're just bootstrapping things in today, so. Note, text probably isn't null terminated string. That's already in our to-do list. Like, we're going to replace the bootstrapped versions of reading these project files later with something better. Okay, so VB project now parses things in theory, but we can't see it, so let's give ourselves some options. Read things out of here. Mouse char star, project name, char star tokenizer definition, file name, and encoding, coding. These are all const. And lastly, we want a static const char star encoding name given an encoding. Let's implement those real quick. I guess those probably go here. Okay, that's ridiculous. I'm trying to save myself work. And one wrong keystroke. Undoes it. This is not exactly rocket science. M_ coding. This one. Turn project, and it's called encoding names. encoding. There we go. Now in our main function, we just blew all kinds of things away. Name is now proj.name. Proj.encoding. Token definition file name. This one though we want PB project encoding name of that thing. Whoa. Align regex, and then semicolon. Not happen at all. Okay, fine, I quit. I'll manually do it. Jeez. Who does this stuff to me? So just a small refactor. Oh. Okay. Guess I didn't actually declare that here. Now I have flexible array member not at end of. Or you have to declare its size. Is that the problem? Think about that. Okay. Static. There we go. We changed the names of things. Let's see. 1, 2. Oh, of course, we rename things. Coding. Oop, nope, that one stays. Error is not member. Okay, that does make sense. That's coding. not have to insert this at all. Okay. I mean, that should just be none by default anywhere. Error. It cannot be, oh, that's because it's an array. And we have to static cast to integer to get that as an index. Easy, done. Whew, tofu the lofu, Emacs Chad. Oh, I've been using it for a while. I'm not bad at it. I've kind of quit trying to improve at it recently. Last few years, haven't really done much. But someday I plan to rebuild my Emacs setup from scratch. So that might be an educational stream someday. Right now, I'm trying to get other things done. Welcome to the stream. Let's see. UV project was not declared. That's because I didn't include it. Yeah, that just goes away. Now we run it, and the name is not correct. Okay, I know exactly what's going on. Because I am a doofus. When we're parsing, we set up local strings here. Equals new character array of Sterling name +1. Then we stir copy into mname the value from name. That's what we should have done in the first place. Bit of a lapse there. All right, compile that bad boy. Okay. Star buffer. What's this? We start copying to the buffer. Then we hand that buffer over to a constant string instead. Buffer equals a new array here. Start copy into the buffer. Set this equal to the buffer. These are actually two different buffers. They just happen to be handled by the same local variable name, but it's being handed off to our class member. There, all clean. And now it's working. So our project name is test. Encoding everything in ASCII, test.vtalk. So our Billy tokenizer. Anything else we need to put in right now? We're parsing the file, which is of course the easiest part. read project file, bootstrapping. Okay, another option. Let's look at our journal. Our design, we said we had to have a project name. We have to have a list of supported encodings. We have to have a tokenizer definition. We are optionally considering a parser definition file. Let's just add that right now anyways. Because it's really not that hard. Since we've got all this code here, we're just going to copy paste it anyway. Our parser definition file name. Parser definition file name. Actually, no, let's not do that right now. Ooh. I want to, but then I run into this problem. I wish that sscanf would return the number of bytes. fscanf advances things. I really don't want to use fscanf. How to know how many characters to advance. Somebody's got to know something. Oh yeah, modulus n. That was it. I knew there was a trick to it. Okay. Yeah, I totally forgot about modulus n. We can do this better. Count is less than 3. Okay. Here's what's going to happen. We're going to scan text. We're just going to get name and then modulus n. Friend bang. Okay. Int pose equals 0. And now count plus equals sscanf text. We're going to call it offset. Pose is not useful. Text plus offset. Modulus n. String thing. Count plus equals sscanf. Text plus offset. Name and size, and then offset plus equals size. I think that's what we want. Encoding name and size, and then offset plus size. Much the same thing here. Modulus n, comma, definition file name, size, offset plus equals size. I don't remember if it in sscanf documentation again. sscanf. Modulus n. Okay. No input is consumed. The corresponding argument shall be a pointer to a signed integer into which will be the number of characters read from the input stream so far by the call to the sscanf function. Does not increment the assignment count returned at the completion of the execution. Good. Perfect. So this is perfect. Let's put all this on the same thing for now. Pretty sure white space is ignored, so we can line things up however we like, and it doesn't matter. There we go. Count has to be greater than or equal to 3. And now, parser definition. Okay. Everything is okay if we have the result. If count is greater than 3, this one is optional. Therefore, you should have a way to know if it is been written to in a meaningful way. We'll set the first character equal to the end of the string character. If parse definition file name sub 0 not equal to the end of the character, we'll do the same thing for parse. Token to parse 1, 2, 3. Clear. There we go. Where do I get my token definition file in? There it is. Okay. If proj.parse definition file name is not equal to null, log note.
What are these for?
Parser. Let's see here. There we are.
They look like that.
Proj.parse definition file name. Else. Oh, Python just stuck in there. None. We might not be generating a parser. People like to write their own parsers. That's fine. Maybe they only want us for our tokenizer. Debug.
Okay.
See what we've broken. AK, yes, get some sleep. Thanks for the visit, for the raid. Always appreciate it. Get some rest. Sleep well. Back to work in the morning. Okay. Int star. Yes, I knew this was going to happen and I forgot to go back and fix it anyways. I want the address of the size. This one as well. Oh, well, shoot. Got an empty string. Oh, just sad, 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 sad. Putting too much white space, is that a problem? Is it going to complain white space things if I never remember all the rules for scanning white space? Still no. Still no. Have I done? Text plus offset. And tells me how many bytes read. Before we get size. Name encoding name definition. And offset plus equals size. I don't know. I think it should work. It'd be fine if it got to here and then failed at this stage. This I could explain away. But to my mind, this should work. Something happened. You know what? No, let's just keep it like this for now. We'll take this out for now. Yeah. Arrays to accept the data. Could not parse required project fields. No. All right. If where it fails, which one? All of them? Could not parse encoding. Expected things. Did I delete something? VP project. Hmm. Could not parse encoding. So I got an error. Why would encoding to encoding name. ASCII lat 1. Okay. Makes everything more consistent if I use the array for everything. Let's see what these errors are about. Left operand of comma operator. Is that really my problem? Those aren't. Sorry, comma operators. Use variable count, that's fine. Ugh. Still getting a null character for encoding.
Nobody helping the baby. How did you get up there? Do I need to look at offset every step of the way? Hopefully it doesn't. I feel like I'm going down a bit of a rabbit hole here. This should not be so easy. 15. "15 characters in" is here. It fails to parse encoding. Looks like this. I guess we can do this. Ooh. Are we requiring new lines at the end? Nothing we do. Do we have to consume the new character? Is that what our problem is? No. Dot P4M.
in the file. This is not. Here I was thinking this would be a simple addition. Instead, we just broke everything. Wait a second. Do a full clean. Maybe I have some lingering artifacts that are killing me. Text plus. I want to see where it thinks we're actually at. Could not parse encoding at 16. New line, and then encoding. This was supposed to be simple. That's the whole file content, so that should be fine. Could not parse encoding. We add 2 bytes. Just add 2 bytes everywhere. Why not? This is Windows. I would not be surprised. Oh, and that brings it all up. Oh my gosh. I know this one works. Let's try backslash r backslash n. What am I doing? Oops. if this is my problem, I will be. Oh gosh, I hate Windows. Neg Vorsa. Hey, welcome to the stream. How's it going? Thanks for dropping in. Okay, so that works. So we can get rid of all this junk. We can put this one back in. First say trailing white space backslash r backslash n. Because we're on Windows, this is all going to go away eventually, so it's fine. This comes back in. Backslash r backslash n. Gosh, Windows. This is why I need to write my own stuff here. Okay. No parser. I have to go to our test. VV project. Parser definition file. Test.v parse. What? Yes, welcome to the stream. We are slowly building the user-facing portion of our own Tokenizer Generator program. Tokenizer generators are not necessary. You can write your own tokenizer pretty trivially by hand. This is more of a hobby, guilty pleasure kind of project for me. I like setting up these automata and processing text. It's going to be a long, slow slog for a while, though. Because we're going to do things that nobody has ever done before. Or at least that I have not seen anyone ever do before in any documentation. La la la. Okay. Or is it more readable like this? Anyway. Parse definition file name. Count. Size. Offset. What kind of input file is this? I am making my own for now. We are bootstrapping our own project file format. Count 3, so it did not get one. Size was 21 bytes, probably from this line. Offset 79. No. Interesting. So just the key value pairs. VVP stands for Vili and Vey project. I'm using Vili and Vey as the names of my Tokenizer generator and my Parser generator because Vili and Vey are the brothers of Odin. Odin breathed life into man after forming him from clay, but Vili and Vey gave mankind language and expression. So I thought those were good names for my Tokenizer and Parser generator. But rolling it all up into a single project file, and we're starting at that top level user layer stuff for now. We will be using the Tokenizer generator to generate Thomson constructed DFAs with my own special sauce on top. So, and honestly, I do not know why sscanf is giving me such a hard time. It should not be so hard. Probably it's streamer brain where I'm just missing something very obvious. So before we read the parser line, we've read 3 fields. We have 22 characters from the last read, which is probably correct. Test EVP. So this is G 22 characters. I mean, 22 Control F. Yeah. So at 57. Later on, we will replace the bootstrapped. Oh. The bootstrapped code we're writing to parse these files with our own generated tokenizer and parser. So for now, this doesn't need to be robust. It just needs to work as long as you know what all of the caveats are. This is just me using it right now. There it is. Whew. I always forget. sscanf. So here's the problem. I did not have a space between some text and a semicolon and a colon, right? If you want it to parse any amount of white space, you put a space in. And it will just gobble the white space up to the next thing that's not white space. I wonder, now that this is working, if I just put a space after here, and I remove the end of line characters, have that just work. It does. Great. So, in other words, we can take any line with leading white space, any number of white spaces up to a semicolon, any number of white spaces followed by a word, followed by any number of white spaces. And it is 0 or more. So this should all just keep on working. White space in scanf matches 0 or more. Yeah, I don't use it that often. So when I do use it, it's always the little things that catch me. Like I forgot about modulus n to keep track of my offsets. Yeah, this is all working. Okay, so we can remove the excess logging here. Then if we test to make sure that our optional field is actually optional. That's all working. And we can see that our parser definition file is here. If we go to our test dot Philly tokenizer, not that one, test.vv project, and we remove it, there's nothing to clean or build, that makes sense. When we run it, we get parser none. Perfect. Oh, okay. I'm gonna put the file in for now. Okay, journal. So we're reading our 4 required fields and our optional field. This we are so far away from, I'm not even gonna deal with that. So project file now parsing. Git status. Git. We can remove the stack dump. Add source makefile. Source name. Let's just add to our git ignore. We're gonna add our special files dot vv project, Billy Bay project, our Billy tokenizer, and our Bay parse files. Parsing project file is bootstrapped. So again, none of that code needs to survive, doesn't need to last, does not need to be robust. That code does not need to be robust, that parser. Yeah, I just mentioned in the book I was reading. Nice. Always nice when there's a nice coincidence of information. Was it you yesterday reading the Modern C book? Is that what you're in? I'm trying to think why somebody would be reading a book with sscan in it, or fscan. Okay, so part 1 done. Back into the journal. Oops. We failed to write tasks, or to do rather. Bootstrapped with just scanf. Next up will be this task. Now that we remember everything there is to know about sscan, the next one will go faster. What? What? Why is that file? I just edited xf doc journal. I added this line here. And I added this text here. So why is git not registering that something has changed? To do, I just changed. What? Git. Oh, that is not true. We cannot ignore org on all things. Git status. Git add doc journal and doc to do. Should we add a doc design? Why not? 3 config files. Project file. Tokenizer definition file. Parser definition file. Required an optional things to consider. We're going to put this in here. Added to project notes. Some design or project file. Project file parses, etc., etc. Okay. Now, git add dot design. Now we can put that in. Now git. Yes. Yes. Okay. Added documentation to the project. I thought it was committed before. But git ignored ECG. Boom. Okay. Back to the journal. Here's what we're doing. We're going to read a tokenizer definition file. Modern C. Yes, I thought that's right. Okay. So let's see here. Background for anybody new in the stream. I have built over the years several tokenizer generators and parser generators of varying qualities, and I've experimented with a lot of different things. You don't have to have either one, so we're talking like Lex and Yak or Flex or Bison. You can write your own tokenizer from hand without too much work, and it's not bad. This is more of a guilty pleasure sort of project for me. Probably unnecessary for 99% of users, but if I make it work and I make it work well, that's great. I love the craft. Now, over the years, I've experimented, built things from the bottom up. Like, hey, how do I create the state machines for these? How do I do this? How do I do that? And built it up from pieces, right? You start with a little piece and then you build up on top of it. After you've done that a few times, you kind of see the scope of the problem better and you understand how everything needs to work. And you've essentially acquired the requirements and you have the whole problem in your head. Then you design it top down. So basically, what does the user see? How does the user interact with it? And that's kind of where we're at right now. Is we're starting at the top and saying, here's what the user wants to type in and run and do. And then everything else should just work. So we're trying to make it, we're dealing with the user layer interface right now in a couple more, hopefully by the end of today we'll start taking a regular expression and turning it into an NFA, a non-deterministic finite automata, which will be more work than we can get done today, but we're working on that user level, trying to make it start working. And a lot of that work is bootstrapping. We'll make it better as we go. But now it's time to read a tokenizer definition file. So, Vilive parse project we don't have one. Okay. Test dot toke. We're going to look at. So here's an old example of one of my things we've built. The token name the actions to take when you acquire that token, and then the regular expression pattern. So the parentheses mean that I can understand when the default action, which is to accept the token, happens. Because most of the time that's what you're going to do. You're just going to accept the token. Discard plus block. Okay, so and I need to be able to parse this trivially right now. It can, again, it's going to be bootstrapped. It's going to be fast, dirty, ugly, don't care. So what we're probably going to do, oops, is we'll have a token name. I like that. Then we will have just read a string, and it can be, let's go to our design document. Tokenizer definition file. Token name. Any amount of white space doesn't matter. Then we're going to have a string, which is going to contain one or more of action codes, then a colon, and then a regular expression. Regexp. Action codes will be thing for discard, or maybe X. What else do we have in there? L for new line. We are not going to start with any of these push or minus things. So I guess we have to have a keep as opposed to the discard. Is that it? Really, most tokenizers are super generic. So I'm just trying to think of what's the easiest way to, let's steal this much here. Straight in here. So instead of discard, we're going to take X. Instead of line, we'll go with that. This now goes away, that goes away. We discard comments. We are not doing block comments. And then the token ID is a keep action. Colon, and then the rest of the regular expression. Do I need the colon? Do I want the colon? This is fast and dirty, so we just grab the string. I think that's good enough. So in theory, we should be able to parse this out by the end of today. And hopefully we get further along. Action codes, one or more. And we don't need the colon. Line-based parser. And again, this is not robust, this is bootstrapped. So bootstrapped. So this is not robust, not final. Same thing for this one. Line-based parser. It's here, I guess a key value parser. Test.vvp key value. I guess it doesn't need to be line-based, just each tokenizer rule has the following form. Okay. So back to this one. This is our test example. Let's get to parsing that. Can you try mxvc next action? VC next action. Yeah, so that's all in there. And I've got my shell. It has added it to be committed, which is not what I want for this file, but that's fine. Did we want to add it for this file? It doesn't matter. Okay. So yes, I do have VC up and running by default, I guess. Okay. Yep. So it's up, it's running. Seems to be working with Git. I just don't use it. I don't know why. I used to use it a lot back in the good old SVN days in my first job out of college, but it just fell out of use for me. It didn't stage the design file though. No, it did not. I noticed that. Just the file I was in. I may be in an old Emacs. Emacs show. Oh, there it is. Since Emacs version 27.2 from 2001. I may be a little out of date. Although, honestly, VC shouldn't be that out of date. Like, it's not like it's changed that much over the years. I don't know. Again, one of these days I need to do just a straight up stream of rebuilding my Emacs configuration from scratch. Okay, so back to it. Actually, we're gonna put that back out for now. Test. I don't know if I want to save my test files. Okay. All right. So project. Here we are. We're definitely parsing all of this stuff. I'm trying to think. I don't want to process the tokenizer definition file unless I know I need it. So if I'm not outputting something, well, we're getting ahead of ourselves. Let's just parse it. Our PvP project needs a tokenizer definition. And a lot of this is gonna, well, let's call it VV tokenizer. This is probably not gonna do what I want. No, it did not. Perfect. That's right. VVT, VVT. Okay, so just like in VB project, We do not need encoding. We need to parse text. Yeah, when you have free time. Yeah, well, maybe one of these days I'll just have some burnout on the project and want to rebuild my Emacs. It's been stagnating, my Emacs config. You got the same behavior? Okay. Maybe if I was in a directory above, or yeah, I don't know. It's been a while since I've used it. Parse text. It's not entirely true, is it? Token definition file name may not be required because we might want to pass in our own tokenizer definition, not from a file. But we're not going to worry about that right now. Overthinking something real quick. PV project needs PV tokenizer definition. PV tokenizer definition. Parse. Okay. Oh, so let's see here. Everybody in this chat, welcome, welcome. If you are new here, you can always get notifications by joining the old Discord server or on Twitch. All of my old videos, older than 2 weeks, are on YouTube and Rumble. You can find those links in the about. And yeah, just give me a follow and keep up to date on what we're working on. Okay, let's see. Tokenizer definition. We're gonna hack it in for now and be happy about it. That's the rule. When you're building things up, you just gotta make it work. Text buffer. Oops. Buffer dot read file from this. Your m_token definition clear. parse our buffer dot content. Okay. In keeping with that pattern, we should be able to clear our project on demand, I guess. Let's start with that. Tokenizer definition. Okay, add it to our make file. We should be up and running. Buff used twice. Okay. Project with tokenizer definition. No return statement. Oops. Return true. Okay. Buff used twice, he says. Oops. I'm fine with that one. Oh, yeah. So this buff is, yeah. So we've fixed that already. Nice. Okay. I think we're good to just test it and see if we can get. Where is it? There we are. So VB tokenizer definition dot parse is called, and the tokenizer definition dot clear is called. Perfect. Text buffer dot. Taking that. Still good. Okay, the main thing we need is a collection of rules. And the thing we're going to run into is we need a container for these rules. Now, we could use std vector, we could use std list. Each of those has their upsides and their downsides. Is there anybody in the chat interested in discussing the various relative merits of using std list or std vector or writing our own container? Do we want to write our own container? While we think about that, oops. We need a VB tokenizer rule. So this will be something or container of VB tokenizer rules. We need to decide that container eventually. So that'll be a thing we need to do. A tokenizer rule. What was the question? Did anybody want to hear a discussion about the difference between using like an std list or an std vector or some other collection to store our stuff in? It basically has to do with how memory is managed and how you then store and access things in it. We're putting lots of things together. It doesn't take long if people are interested, but I don't know how many people are. Yeah, let's go. Okay, scratch buffer time. We talked about C strings, null terminated strings. Okay, std list. We'll get to std vector in a second. Std list of something, right? Maybe it's integer. Let's go ahead and just make it an integer for now. It's very, very good at growing and shrinking if it's not a large number of items. So let's talk about what this means. What it means is inside this thing, what you have are nodes. Let's define a list node. This is all pseudocode, it's not real. And what happens is this node is going to have this integer data, right? So this integer is what's being stored. And it's going to have a list node star next. Okay? And when we make this list, we're going to have a special list node pointer called head. And that's basically almost everything you need. So when you create a new list, this head is going to be equal to null pointer. And when you append void std list int append, right? Again, this is not real C++, don't worry about it. We will take some value and we'll say if head is null, then our head equals a new list node. And our list node dot data equals the value. And then we'll say the list node next, it's going to point to nothing. Okay, so that handles our list is empty case. If our list isn't empty, we're going to walk forward from each node from head until we find one whose next is null, right? So list node pointer temp equals head, while temp points to next is not equal to null pointer. temp equals temp.to next. And then here, once we found a node whose next node is null, temp.to next equals null pointer equals new list node. Temp.to next dot data equals equals our value. So what happens is you have memory looking like this. You have a list object, right? And it has a head pointer that points to a block of memory, which contains data, and it contains a next pointer. And this next pointer can either point to another node, or indentation. It can point to nothing. We know we're at the end of the list when we have nothing. Does that make sense? Head.data. Yeah, probably. Okay. Head dot. Yes. That's what I meant. You are correct. So we have a class that contains a pointer to some actual memory, which contains a pointer to the next memory, which contains a pointer to either the next memory or nothing, right? So if you want to know how long that list is, you have to walk over all n elements to find the last element and count them. You don't have to. You could store it, and as you append, you increase the size that you store, but it's a similar idea. If you want to say, is the value 5 in this list, you have to walk forward over each of these in order, and until you find the one whose data is 5, right? If you want to append, you have to do this. You have to walk all the way forward and then append to it. There are some optimizations you can do, but basically accessing memory inside of the list is not efficient. It'll grow and shrink very quickly. Adding and subtracting from the head, like if you want to pop things off the head or push things onto the head, is very efficient. Depending on their implementation, it may have a tail as well, a pointer basically to the last thing in the node. So that would be more bookkeeping every time you insert and remove things. Right? So it's just one more thing we have to keep track of is the end, but it makes append easier because we don't have to do this. We can just say, give me the tail and go, right? But then you also have to say temp.to next. You have to say tail equals temp.to next, right? If you have a tail, there's lots of different things you can do with list, and you can make very efficient moves at the beginning and at the end, but traversing the whole list is very expensive because you have to keep looking up pointers and dereferencing pointers, and they're probably not good cache hits. So there's a lot of reasons not to use list, a lot of reasons you can use list. Singly linked list, you could go doubly linked as well, so you could have, I mean, these are all just variations on a thing, right? Where you also now have to keep track of where did you come from. Yeah, these are all options. It grows and gets more complicated the more you try to optimize different things, and then the amount of bookkeeping in here goes up or down, depending on appending and removing, finding. This is the basic idea. You have a whole lot of non-contiguous memory pointing to each other. Your CPU really likes your data to come in blocks. It preloads a block, and as long as the memory you keep requesting is in that block, it's just hitting a cache and not hitting your RAM. If you think about the order of magnitude of operations on your computer, your CPU is screaming fast. Anything that happens within the registers of your CPU is unbelievably fast. You have no idea. if it has to go get data that's not in the registers, it really wants to hit the cache and get it there, because that cache is fast. You have L1, L2, L3 cache these days. Don't worry about that. Just know the cache is fast. So as long as your data is in that cache, it's fine. But if you have to go all the way out to RAM, if you miss the cache, and you have to go out to RAM and get that data into your cache and then into your CPU, that's slower. Okay, so if these two addresses, if this block of memory and this block of memory are not next to each other in your list, you're now doing a lot of cache misses and hitting RAM more often instead of preloading blocks of data. This is where the list, no matter how you optimize it, is really, really bad. Non-contiguous blocks of memory. Okay? Let's get a divider here. A vector, and again, whatever type you want, is different. It has, let's see here, it's going to be, have an int capacity, an int size, and it will have a an integer pointer buffer. Call it a buffer, call it a store, whatever, doesn't matter. And what's going to happen is when you append to it, append some integer value, what it's going to do, let's give it some brackets, it's a function, even if it's crappy, not pseudocode. What's going to happen is it's going to say if our size is greater than or equal to our capacity. Okay, so if we start with default 0, we have no capacity, we have no size, and our buffer equals null. Okay. Actually, I've seen different implementations. Let's say that you start with a capacity of 12. This equals a new integer array of 12. Okay, so this is contiguous memory now. That's 12 integers in a row. Okay. What we're going to say is if our size is at the capacity, we have to add pseudocode time. Say our buffer. We say a temp buffer equals a new integer array that is 2 times the size of our last capacity. Then we copy size elements from buffer to our temp buffer. Then we delete our buffer. So we're deleting the memory that the buffer is pointing to. And then we set our buffer equal to point to this temporary buffer we made. Okay? So now what you have is your vector, and I don't like the word vector, they call it a vector. Worst name ever. Worst name ever. Because a vector has mathematical meaning already. What this is actually called a dynamic array in any language that makes any sense at all to anybody. Okay? A vector, so I'm going to call this dynamic array because that makes so much more sense. There's stupid std vector. Gosh. Okay. It doesn't make me mad, I promise. What it contains is the memory for capacity. This never changes. Oh, and then we also set our capacity. Capacity equals capacity times 2. And then otherwise, sorry. Not otherwise, it's just always. Since at this point we're always guaranteed to have more capacity, we can say buffer at size equals our new value, and then size plus equals 1 to increment what our size is. There, done. That's the append. All we ever have is capacity. This memory never changes. We have a size, which memory never changes as you insert and remove things. In terms of where it is, this is all staying. And then we just have this buffer that we keep deleting and recreating over and over again and recopying data over and over again. So if you're making a very small collection of data and you're hovering around the lines where capacity doubles or halves, it's constantly copying your data over and over again. So if you're growing and shrinking things a lot, vector is really, really bad because it's constantly deleting memory and allocating new memory. But if your memory pattern is to grow and then stop and stay that way, this is very efficient. Memory access, I don't have to walk forward. I get all this memory in a block. When I ask for the next one, it's just an index into memory that I've already probably pre-cached. And it's very, very efficient. My problem is the copy-delete cycle. In a lot of cases, this can be very punishing. So to add an item, like let's say that you're hovering right on this line between 12. You keep adding and removing items around this 12, 13. Create, delete. Copy 12 items, copy 12 items over and over again. So if we remove it, it's a similar operation, but we shrink it by half if we can. So if you're thrashing across that, vectors can shrink depending on the implementation. I've seen vectors start with capacity 1 and grow not as, doubling. Doubling seems to be the most normal because you get that logarithmic memory behavior where if you're allocating millions of elements, really the first few copies and reallocations don't cost you much compared to the overall thing. Vec doesn't reallocate on the 3 major compilers on arrays. That could be vector does std vector reduce in capacity. Maybe it's part of the standard now. I don't know. Blah blah blah. Stack Overflow knows everything. C++ 14 says things. Capacity is larger than the size of mean. Blah blah blah. Yeah. So it looks like it doesn't. There is a shrink to fit method. So I guess you'd have to manually shrink to fit. Yes, if calling fit size function. So again, it depends on whether you value your memory more or your performance more. So I guess it just grows. So as long as your data just grows, it's reasonably efficient. Now you could end up at the point where you're at 1023 elements, and making that 1024th element would bump you into another doubling. Then you now have half memory that you're not actually using. So you could end up with half your memory being tied up that you don't need to have tied up. In which case, maybe the fit size function is a good one. Yeah. So vectors, much better access patterns. Dun, dun, dun. So those are my 2 lists, my 2 collections. In this case, what we're going to do is we're going to read through a file 1 line at a time, and for now it's going to be line-based, it's fine. We're reading through a file 1 line at a time, and what? We're just going to keep adding to the end until we hit the end, and then so this is actually a good use case, I think, for std vector, if we want to use std vector. Do we want to use std vector, or do we want to write our own custom container to kind of show you what sorts of things go into it? Vector. Yeah, so good catch, angered gecko. You're right, it does not resize down unless you tell it to. Oh, by the way, welcome to the channel, welcome to the chat. Tokenizer definition. That's not what I wanted. I want the header file. So we just need to decide what container to use for our rules. Now, a tokenizer rule is somewhat of an expensive copy, so we might not want to do that. There is a third option, writing compiler from scratch. Never done it before. It's kind of fun. Yeah, so okay, let me back up and give you the background. I've written lots of little pieces of different compilers over the years, until I think I've got a pretty clear picture of the whole shoot and match from like a bottom-up exploration. So I think we're doing a top-down design now, where we're starting with the user's experience, and then we'll slowly build out downwards as we go, because I know how the lower level stuff all works. The Tokenizer Generator is not necessary. You can easily write your own tokenizer from scratch. This is more of like a guilty pleasure fun project for me. I like the working in the NFA, DFA worlds, so I'm not saying everyone should go write their own tokenizer generator, but I like it, so we're gonna do this. Okay. Yeah, give a follow along, etc., etc. Maybe it's time to plug the old Discord. I've been watching people, they have like these bots and stuff that automatically spams their Discord. I'm not that tech savvy yet. I don't really think of myself as a streamer yet. I still think of myself as just a programmer who happens to stream, so all those notifications and things I haven't set up yet. Okay, so we need a container. STD vector would do a lot of copies, potentially. So here's a third option. Let's go to start scratch. So we've talked about list, and again, there's a lot of variations on this. Doubly linked list, you could use a vector. Copies are expensive, so adding information can cause large blocks to recopy themselves over and over again. Let's look at a third option, and this is one I'm kind of leaning towards. And yeah, if chat wants me to stop, I could stream writing a stream bot. Yes, that sounds very recursive. I'm going to call this one a bucket array. So I don't think there's an equivalent in the standard library. Correct me if I'm wrong. But basically, the idea is you have a bucket size, a bucket count, and then you have basically a linked list of arrays. I'm going to have a so this is the data type here. Let's make this. Let's see here. I'm going to just change some of these integers to characters so that it's more clear what's data and what is like bookkeeping. So capacity and size are just integers. This char star buffer is the type of the template. Append a char value, a new array of char, byte array. These are integers. Okay. Then we have a char star buckets. Well, again, it's more of a, it should look like std list of character arrays of our bucket size. This is kind of the pattern that we would use. So as you go, you append things to it. You get your first bucket, and it's however long bucket size. Maybe it's 16 elements, and you fill up 16 things in it easily, just like you would a vector, until you hit your capacity. Once you hit your capacity, instead of doing a complete reallocation of everything and recopying everything, all you do is you append a new bucket and keep going. So you're not going to get a lot of copies, and as long as you're just growing and it's not huge, like the time when vectors shine is with large data sets. of simple data types, because the copy needs to be somewhat trivial, and you get that logarithmic behavior. We're honestly never going to have 20, 30 array elements. So having a bucket that allocates a bucket array that allocates 2 buckets is probably going to be more efficient than a vector growing to the size we need. But we would have to write this ourselves. So it's a question of developer time. Deck. A deck is like a 2-ended linked list. And you have efficient access at the head and at the tail. But not in the middle. Not efficient access. And you get the same sorts of issues with the STD list, where your memory may not be contiguous. STD deck is implemented like that in Major 3. Really? Deck is implemented as a bucket array? Except MSVC. Yeah, MSVC. We don't talk about Microsoft Visual Studio. Visual Code, Visual C. Deck is implemented as a bucket array? Really? I thought it was just a doubly linked list. A deck is somewhat recursively defined. Internally, it maintains a double-ended queue of chunks of fixed size. Each chunk is a vector. The queue of chunks itself is also a vector. Oh, so it's actually using vectors of vectors. A vector of vectors. Now, your vector, if you pre-allocate it with a known size, does not double and does not copy. So that's good. That's probably what they're doing then. Since your bucket size is probably determined. Okay. So I guess that raises the question. What do we want to do? Do we want to make our own container called a bucket array? Or do we want to use the deck? Vector of vectors. If we're going to do something built in, it's just going to be a vector. We'll eat the performance cost because it's honestly not the bottleneck. But we could write our own bucket array, which might be informative. Is that worth it? I don't know. Educational. Tell you what, chat, we'll leave it up to you. Do you want to write a bucket array, or should we just use vector and get moving? Vector. We love vector. Okay, we can do that. If we ever decide we hate vector enough, or if it's performance an issue enough, we can always go back and change it. So this is a fairly low cost choice to make. So hopefully that helps people understand why we would use different containers. Vector is probably going to behave just fine in this application. All right. So let's go get vector. If only I can type. A lot of this is not because we have to, but more for the educational experience. So if you guys wanted to do the other thing, we could definitely do the other thing. But we'll start with this. Okay, so parse and clear. So clear is going to be easy. mrules dot, I think it's clear, right? STE. Better pull up the old documentation, all the different function names. Yep, just clear. Parse. Okay, if while we're parsing we find an error, we'll do that. Okay. So if we go to VB project parse, we'll follow some of the patterns there. We need a name, a token name, we need the actions string, and we need the regex. So name, actions, regex. I always forget. Escape brackets. There we go. Again, this doesn't have to be robust. We just need to get it bootstrapped. Okay. We want the first thing. We want the second thing. And we want the third thing. This will be name, actions, and regex. And that is it. This is even more static and unoptional than the last file we parsed. So if count is not equal to 3, we have a problem. Tokenizer definition not parsed, could not parse. Parse, yes. Actually, let me here. We're going to do this inside of a loop. We need to count 3 fields. Oops. Okay. If count equals 0, we can break. In other words, if we get to this point and we can't read the next name, then we're done. We don't have any more rules to parse. Otherwise, if we have like 1 or 2, that means that we got the name and the actions, or maybe we just got the name, but we did not get actions and regex. So we can throw that as an error. End of input probably. If count is less than 3, greater than 0. Actually, there's no else here. Else if, oh, let's do this. If count equals 3, we'll do the normal thing. Otherwise, it's an error because we have a count that's not 1, that's not 0, that's not 3. Count equals 3. That means we can go m_rules dot mplace back our thing. I think we just give it name, actions, regex. Okay, maybe tokenizer rule needs to take 3 strings. Char star name, name, actions, and regex. We probably need those. Tokenizer rule. Oops. So we can only make a rule if we have all the information. If a name is not equal to null, pointer, delete name, actions, and name regex. And this is basically access only. No, we don't need to modify anything about this as we go. So this is going to be fairly trivial. Implement this containers. Oh, almost there. Turn and underscore name. Oops. And regex. One thing we're going to add is the option to just log the whole token. Modulus S, modulus S, modulus S, modulus S. That's basically it. Prefix, name, actions, regex. I'm gonna put everything inside of quotes. Just so if there's like trailing white space or weird stuff, we can see it. We need to add this to our make file. See if it compiles. This will be a Lexer generator. Yes. So for those in the chat who are new to the compiler lingo, the phases of the compiler are to tokenize, to parse, to semantic analysis, to generation and optimization. In rough terminology. The one that people can't seem to agree on a name on is the first part, where we take a stream of characters, a bunch of letters, and break it up into words, just like humans reading like English, right? The spaces and the punctuation tell you about the where the word starts and ends. Then you make meaning out of the words. It's called a lexer because it yields lexemes, or one piece of text worth of meaning. So lexemes, lexer. Tokenizer because it returns tokens, again, who cares? And then a scanner. I've also heard it called scanner. So if you hear any of those three words, it's probably the same darn thing. Very overloaded. Then a parser takes each of those, and again, using syntax just like English with commas and periods and the rules of English, you assemble it into a structure. So you have your subject, your verb, your noun, your adjectives, your adverbs. They modify the nouns and the verbs. There's rules about all that. So your parser takes the stream of tokens and puts structure into it. After that, getting meaning out of it is a whole different beast. The first two parts of the compiler are probably the best understood, easiest to build. So we're going out of our way a little bit to make it harder by writing our own Lexer generator instead of a Lexer. You can pretty trivially write your own Lexer without struggling too much. 4:17 and I haven't even had a snack yet. What's going on? Did that really compile? Oh, right. Okay. Name equals new character array of strlen of name plus one str copy into m name, the name string. Name to actions. And name to regex. So we're making a copy of all these strings. This is probably why the vector may not be a great choice. These copies. But we don't want to take ownership. That actually presupposes quite a bit. Ran 1993, best viewers on Alaraka. See, somebody's got a bot running in here. I knew it. It's actually kind of funny. So on YouTube, I occasionally get a real comment of my old videos. But on Rumble, I think I have more subscribers that are offering to help me get more viewers than I have actual subscribers. So it's always sad. But I also figure I'm not really doing this to build a huge crowd. Like if I was, I would not be doing compilers. I would either have to be a lot better looking, have a much nicer voice, or play games, or all three, honestly. If you have a nice accent, I hear that helps. So we're getting a select group of followers that are actually interested in the topics, which I don't know of how any subscriber farmer would ever be able to because I know these rules are going into a vector. I know we're going to do a lot of copies, which means this and this are going to happen a lot, potentially. which means it might be a good idea. Nope. Nope. We're just gonna do it like this. Even if it's performance hit at this point, I don't care. This is not the generated code that will go into somebody else's compiler. So this can afford to be slow, and if you have more than 50 rules, I would be very surprised. So I think this is okay. Not great, not optimal, but it's probably fine. You notice the skeleton? Yes, my Copilot. It's about as useful as, well, Copilot. Or I tell people it's my old coworker. I actually used to keep my skeleton in my closet, but now my closet is full of board games instead, so. Okay. Sheesh. Star buffer.
Where is the baby? Okay, here I am having a heart attack.
Okay. Buffer, copy things into the buffer. And lastly, buffer, copy into the buffer. This feels like a pattern. No, it's a medical. Actually, it's plastic, I guess. Skeleton duck. Savage Lord Severus. Yes, rubber duck debugging. My son did 3D print me a little tiny dapper duck when we were first getting started. I don't know if there's enough delay. I can't see if it's actually in focus or anything useful. But I have upgraded. I no longer rubber duck debug. I talk to chat, and chat tells me what's wrong. Actually, if you go back and look at over 60 hours of streaming videos, they don't usually tell me what's wrong. What? Never heard of rubber duck debugging? I became a big fan of rubber duck debugging in my first job. Skeleton debugging. Yes, we do printf debugging and skeleton debugging. Those are my two kinds. Yeah, I noticed the more times that you try to explain your stupid problem to somebody, halfway through you'd be like, "Oh, I'm an idiot," and you'd remember what important thing you should have remembered that you didn't remember. So, welcome to the stream, Savage Lord Severus. Always good to have new people popping into the chat. We're building a Tokenizer Generator, or Lexer Generator, or Scanner Generator, because we can, not because it's the right thing to do. I like building DFA state machines that use features only available in GCC. And that's what we're going to do over the next long while. Most of the time, we do some game development with no game engine. But Friday is variety day, so you get compilers, or sometimes other things. So welcome aboard. Oh, I guess there's enough people in now. Should probably plug my Discord again. I need to get a bot for that. Or write a bot, or I don't know, it sounds like work though. Oops. And then I would start feeling like an actual streamer instead of a programmer who happens to stream. Tough life, right? There's a Discord if you want to get notifications. I also have a Twitch where I send out the notifications. If you want videos older than 14 days, I've got a YouTube and a Rumble channel. Always happy to have more people chit-chatting. But back to work. Back to work. What even happened? Okay, it compiled. Now, tokenizer definition. Let's add a log function to that. Tokenizer definition void log const. Because as I write these little parsers, it's really good to, know what it is you're actually getting. Rules dot. I think they use size. That's another piece of STD that I don't like. The use of size instead of length. Like for me, size, I've been trying to be more and more consistent about saying size equals bytes of data, and length, or maybe count, is the number of things in it. But that's not what STD decided on. They said size means the number of things in it. So, pet peeve, whatever. Savage Lord Severus. It's actually good. I came in, I was thinking of helping add list comprehension to Godot. Or Godot. How do you pronounce that? Maybe being good at regex has made me overconfident though, lol. Well, we're going to do regex in a way you may not have ever seen. We're going to do it. We're going to build our own NFA from the string. We're going to build our own DFA. Godot. Okay. French style. Wouldn't that be something more like this, though? And I'm joking. I don't know French, except there's always a lot extra vowels at the end of the word, a lot of extra letters at the end of the word that you don't say. Pero yo hablo un poquito de español, aunque, no sé, es bien feo mi acento. Like Merlot. Okay, that's fair. So maybe, okay. That makes sense. Merlot. Okay. Um, for each, well, just go int 0 index less than rules.size plus index. And actually, I have found. No, that's fine. That's fine. Fine. Log note. No, not log note. We want m_rules at index dot log with a nice index as a prefix. That weird thought that just flashed through your brain. No, you're not the only one who's reminded of WoW when he reads Murloc. Yes. I don't know. Languages are fascinating, but French doesn't hit the top of my list. I know English. I'm conversant in Spanish. I would not say that I'm fluent. It's been too long. Not enough people to practice with. Occasionally listen to some Spanish music. Mostly South American, not Spain Spanish. But yeah, like I think above that, above most other languages, I'm thinking Russian and I'm thinking Irish. Russian because it's a class 3 language that requires a different alphabet that also buys you a whole bunch of other languages as their alphabet, right? You get a lot of those, yeah, a lot of those other languages, like for example, even like Mongolian, right? So Mongolian uses a Cyrillic alphabet. Lots of languages use a Cyrillic alphabet. So that would be a cool one. And just to prove you can, class 3 languages just means it's hard to learn from English. And then Irish I want to learn because it's frankly a dying language. Even the Irish can't speak Irish, so. This side of the pond, they make us learn French in school, so we learn to hate it. Or, I was school 24 years ago, no idea what they do now. Yeah, fair enough. So if you're saying this side of the pond, that probably means you're in the UK somewhere. Is that right? We should add a log to this as well. Yes, we can. Which roughly looks like that. proj.log. Where's clear? Log const. And actually, all we do then is m underscore toke def dot log. See how that looks. That is right. Yes. I get some weird time zones in this chat, honestly. I'm doing a small amount of rum tonight. Excellent. As my clients just gracefully let me know today that they won't, after all, be renewing my contract in 3 days. Ouch, because they're restructuring their entire company from CDO down. Ouch, that's rough. I'm sorry to hear that. Now is not a good time to be without a job, at least in the US. I don't know what the job market looks like in the UK, but oof, 3 days notice is not much. Did you have a good, is there a good contract, like renewal or termination clause that buys you some transition time? I think exit clauses are important. Like, again, not knowing the terms of your contract, something like you need to give me 2 weeks notice that you're not renewing the contract, otherwise there's a financial penalty, those kinds of things, just so that it encourages not being caught by surprise. Business to business, they just decide it's done and it's done. That's rough. What industry are you in? I don't know if that's a standard contract thing in your industry or what. I must be a doofus and did not put const after log. So for those who don't know C++, this const after the function is basically a promise to the compiler that I'm not going to change anything inside my class while you're in this function. Clear is a function that definitely changes this stuff, so I can't promise that it's constant. So if I've got a constant reference to this object, there are things I won't be able to do with it. So I have to be aware of when things are constant or not. Oops. Software consultant smarter than your average web dev. I mean, let's be fair. Who isn't smarter than the average web dev? They think that HTML and CSS are coding. JTL, you are not a web dev. You, well, are you a web dev? I know you've done the web page for our other business in Squarespace. I guess you did do some lower level stuff to get your JavaScript in there. That's true. I take it back. You are. Severus, we charge more for our time, so I should start consulting, being consulted. Not right now. The market sucks. Oh yeah, the market sucks. Okay. Only on the side. I don't remember what the compile output was. Oh, warnings. Oh, no warnings. I'm probably too aggressive about warnings, but I've bet so many so many. So many companies where the code base is so full of warnings that you actually miss important things. All right. Well, we definitely have an issue. Fire up the old debugger. Okay. No stack. Boy, it really crashed hard, didn't it? Ouch. I'm not saying web devs are dumb. I can't do my job without web devs. I distinguish myself from employees with deliverables. I also provide team leadership training, etc. Yeah. Well, I'll tell you what. You can keep the team leadership. I hated it. I quit my last job because I was in charge of a team that. Ugh. And the consultant title, my coding makes me web dev too. Okay. But there are some good web devs and there are some really bad web devs. Lots of the latter. Stack dump. You know how long it's been since I've looked at stack dump? Yeah. Well, I wasn't even dragged into it. Like, it was just, there's this opportunity. They're like, hey, how'd you like to start up and lead this team? I was like, great, I get to start my own team. Hooray. But then, like, I only had one dysfunctional employee from the company before I got there, which there were reasons we couldn't fire. And then, yeah, it was a disaster. I was always behind, couldn't get caught up. My employees weren't really keeping up, and nothing. Like, I could not impress upon them their priorities. Apparently, we fired people. Yes. And it just became a big freaking nightmare. Like, in my mind, and this is maybe just the way I work, if you say, here's your list of things to do, and here's the priorities, like, I'm going to tackle the top priority thing, and then the next thing, and the next thing, and I'm going to work my way through that list. And when you ask me, hey, what's been done? I can go, this is done, this is done, this is done, this is done. And this one I didn't get to. And they'll be like, oh, okay. But that's not apparently how most employees work, at least not the ones I was working with. It was, apparently nobody took any pride in their workmanship or something. You were dragged. Yeah, well, I thought at the time, hey, maybe I could become good at management and enjoy it with given enough time, right? It's like this is the natural progression of management of your career, right? You learn things, you go from being an idiot to slightly less of an incompetent fool, and then before long you're in charge of a team where you don't have to know everything, but you've seen enough stuff that you can kind of, work around it and help other people navigate. But that's not what happened at all. So I don't know what to say about it. All right, GDB, how to load a stack dump. I don't do this that often. Usually I just get there through. Okay, come on, inner Googles. Is it just me or has Google gotten worse at answering simple questions? Dash GTDB, otherwise the stack deep dump info is useless. Okay, look at our makefile. Dash optimization 0. Run it in the debugger. Stack dump. In theory, there might be useful stuff in this file. Quit. vv.exe.stackdump. Frame function args. End of stack trace. See, this is loaded modules. Holy crap. Almost none of this is actually in my compile at all. It's just like, here's a whole ton of stuff. Hate that. Hate. Yeah, this is useless. I'd have to look up these addresses myself. We're going to do this the old-fashioned way. Printf debugging. I always keep coming back to it. I keep trying to use tools, and they let me down. Looks like Sigwin. Yep. Well, yeah, an unholy environment of MSys with MingW and Sigwin, and yeah, it's, ugh. Yes, we're in Windows. Fun started. Yes, fun. This is fun. Well, compiled with debug and no optimizations. Yep. And still the stack dump is useless. Unless I want to go look up memory addresses, which I don't really want to do. So printf debugging it is. So question 1, the VV Tokenizer definition dot CPP. We are stating. Oh. It should clear itself. It should state when it's done. So we can bisect it at this point. Begin. And end. VV project, it may. Let's see, where are we at?
Now, just what is he doing? Using it.
If the result is positive, we get our text buffer, we give it the token definition file.
Just get a print back.
Oh, that's the last thing that happens. And then in log,
Blanket, please.
VV project. Yeah, that's fine. Okay, that makes sense. Well, if anybody in the chat knows of somebody that needs work, I'm looking for work, and Savage Lord Severus is looking for work. So I do not believe Sigwin does supply Valgrind. I have here Sigwin Valgrind. I don't think so.
But I'll be right back. I need what?
I use DR memory with MingW, but if Sigwin can use Valgrind, Doctor memory. Okay, maybe we use Doctor memory. Let's just see if we can find it. We'll do it the hard way. Honestly, since I was, I started off in fsanitize address. Oh, come on. Berg. Who does this to people? Who designs UIs thusly? Fine. Anything to stop me from debugging memory issues. Well, right now the project is small enough, it's probably easier than. Just like froze up there, dash F sanitize. I would copy it, but the in the comment icon pops up over and I can't get it. Equals address. Have your own LLC. Okay, so right now I am unemployed and the streaming is more to pass the time and to, I guess, network or whatever while I try new fun things. If I happen to get a following, wonderful. If not, well, I'm going to release a game here in the next few months, hopefully. Simple game, because it's a learning game, maintaining my small scope. But me and my brother-in-law did form an LLC. We have a product. It's for sale. It's nothing anybody in this chat room would ever buy. Sanitize is misspelled. So that is true. So yeah, there's the LLC thing. Cannot find.
Oh, that's where it was.
See, every time I try to use tools, I'm just left disappointed. Just disappointed. We'll printf debug this. What is it? Jonathan Blow calls it cowabunga debugging. But honestly, people these days have no idea how good they have it. Oh, interesting. Okay, so it does not begin. Rules clear. It does not end though. So people don't know how lucky they have it having printf debugging. When I was starting out, there was some projects with a bare microcontroller. So just C on a microcontroller, no operating system. You had to write your own event loop and interrupt vector handling, etc., etc. All you had to debug on was an LED. So if you ever did LED debugging, printf debugging is just glorious. It's wonderful. So wonderful. We have it so nice. Debugging is like being the detective in a murder mystery where you're also the murderer. Yeah, isn't that one of the things is you should code like the person who's going to look at your code after you is a psychopath and the worst coder you've ever seen is yourself from 2 weeks ago. I always took that to be kind of circular in that you should code as though you are a psychopath 2 weeks from now. I'm going to come back and look at your code. So it's more like an unintentional homicide. Looking for a rule. Let's indented. End of input. Bottom. And error. If there is an error, might as well break. Yeah, I always tell people the person they hire next is an axe murderer who knows where you live. Yes. Looking for a rule, looking for a rule, looking for a rule. I only put in like 4 rules, right? Test.vb. No, not that one. Test.billy tokenizer. Put in 4. that. Oh, so that definitely raises the. Let me see here. See if I can find it real quick. Post it up. Let's see here. Let's type this up. I only can find images of it for some reason, so. One. Three. Four. Five. Six. There you go. We'll put that in the chat. Boom. Yes, we make these jokes, but we have only ourselves to blame. Exactly. We are the ones who chose a career where a string and a thread are two completely different things, and where a vector is not a math concept, but an allocation of memory for a container. Gosh. Which stage am I in right now? Oh, that didn't come out very well at all. Thank you, Twitch, for not having new line characters. I love the web. Don't. Where am I? I'm in the stage 4. is web page white space sore point? Oh, they asked me what a closure is. Oh, yes. Closure is always fun. What happens if you have more than 3 words per line? I was like, well, technically it's a math term meaning a function applied to a number in a set will also result in a number in that set, or do you mean any piece of code in JavaScript enclosed in brackets? Closure is when you do an operation on a set and the result is still in the set. Yes, exactly. You didn't get the job. See, we're going to talk about closures 2 times building this code. We're doing a tokenizer generator, and to compute the DFA from the NFA, you have to take a closure. And the same thing with the LALR parser generator. Also, the closure is you have to take a closure of the state you're in. So yeah, that is hilarious that they did not accept that as a valid computer science answer. Ridiculous. By the way, why make DFA from NFA? Yes, that is a whole discussion. Simulating NFA isn't too bad, is it? Okay. Here's the discussion. An NFA is great if you don't know the regular expression at compile time. So if a user types an input and you hit go and it's used once, the NFA is more efficient because you basically walk only the parts that you need to and you're done. The DFA says, let's take every ambiguous state and create a new state and then progress from there. It rebuilds everything so there's no ambiguity period at all ever. There are no lambda transitions for those that are in the computer science world. So what that does is it has to walk every possible path of the DFA of the NFA to build the DFA. Basically, if you make a choice, you have to take both. But then if you know two things can happen. One, if you're using the regular expression a lot, well, now it's walking the NFA, and every time it goes through, it's choosing ambiguity. It has to try one path, and if it doesn't succeed, it has to backtrack and go to the other one. If you go all the way to DFA, there's never ambiguity. And so you can always just walk forward and never backtrack. So it's more efficient if you're going to use a regular expression a lot, or if you know it at compile time. In our case, we know it at compile time, and we're going to actually build an entire jump table out of labels and go-tos so that we don't even have function call overhead or array lookup overheads. We're just going to jump to the address. We can do NFA without backtracking because it's finite size. Right, but you do have to try. Let's see here. What's the answer? You can do an NFA, but you can't do it. You have ambiguous states. So you have to check the next character and not necessarily take that branch. Anyways, a lot of regular expressions nowadays are backtracking anyways, and I don't like it. So we're going to not implement backtracking either. Yeah. The NFA I can compile to a jump table and just use go-tos. I don't think you can do that with an NFA. Okay. Number one possibility. Oh, well, hold on a second. What about? I need maybe Tokenizer definition. I might know what's going on. Okay. Instead of counting, bool valid equals true. If valid equals it's going to wrap everything valid. Sure, that's fine. Basically, we're not going to run all three scanfs after we've hit the end. I think that's part of the problem. So the first one doesn't scan. It does not do these next two. If do you keep track of the count as well? Do we know how many of these words we got through before it failed? Equals 0. Take a look. I am, that is you. Okay, so let's hear. Where am I at? I don't think you can just do go-tos. Yes. So the NFAs, with a DFA, I can do just go-tos. The whole thing can fit inside of one function. It's all go-tos when it's converted to machine code. Yes, but I can control the go-tos much more. Okay. Yes, it is, but there's also function calls which have frame. Good gracious, I just blanked. you have all the frame data that's every time you push a function, pop a function off the stack. I can literally do it with one function call into the parser and then just go-tos from there, period. So there's no function call overhead at all. One state transition could involve up to n go-tos instead of one. If you're talking about the NFA, yes. In a DFA, there's only ever one go-to per state transition. In this channel, just people that no one wants to sit next to at a wedding. You know, you're not wrong. I am me, that is you. Hello. Welcome to the stream. Servers or servers, I don't know. I don't care. We'll have our own table. I could talk about this all day. We are going to talk about this all day. Actually, yeah. Even a function call is just a go-to with return address. No, there's more that happens on the CPU than just a go-to with a return address. You have to dump your parameters into memory in a place where the new function has access to it. You have to include your return address, and you have to, on ending that function, copy any resulting memory into the return memory space. And it's not as simple. You also it also has to maintain register states. You believe in your compiler to inline for me. Nope, I think I can beat the compiler. And we will implement it multiple ways. We will implement it so that it's a function call. We will implement it so that it's a table of function pointers. And we will implement it so that it's just go-tos. And I will compare them. Because I do want to know how much. I'm 99% sure that my go-tos are going to be faster than a bunch of function calls. But I don't know how much. I was being facetious, but that was an elegant explanation. Worth it. Yes, good time. All right. Now what am I doing? I expected a semicolon. So I probably there. Oh, valid equals. Put your code on GitHub. I'll implement the NFA way too. Ooh, interesting offer. The only things I put on GitHub are very small projects. Like I wrote some example random number generation stuff. What did we do? We did a Parsing twister, linear congruential, GB flip, and Isaac random number generators. And then some examples of the different uses of it, including uniform number distributions, Gaussian distributed using Box-Mueller form. We did some examples. We did like Perlin noise, things like that. But I don't want to contribute large projects because I don't believe in feeding the AI that wants to replace me. I don't want to give it samples of code that do interesting, unique things. But implementing it in an NFA way, that might actually be worth making it available to someone else. Here's something I want to learn better: maze navigation. Yes, maze navigation is interesting, and navigation is always interesting. Follow the left wall and skip the challenge. Yeah. Do you have it? Okay, so it depends if you have full maze knowledge before you start or not. Then you can do like, okay, so I sent a video to my son a while ago. No loops, yeah. Okay, so if you have full knowledge, A star search is going to be your big one. But no maze knowledge is cooler. So I gotta find this video. And I don't know if I can find it on this account because I don't have a history here. This is just my streaming account, so I don't have race. It's this one. This video. Copy the link, put it in the chat. Is it this movie? Yes. Boom. Okay. So there are these micro mouse robot maze races. And when they start, the mouse does not know the map. If you watch this video, it talks about the different algorithms they use. I think it's a flood fill algorithm. And it's fascinating, actually, very fascinating. Not just on the mechanical side either. Be right back. Cool, Ingrid Gecko. Looking forward to it. So what happens is they do what's called, well, I mean, this is exactly what you're looking for if you have no maze knowledge. Flood fill is the one I want to learn. Yep. If you don't have knowledge, flood fill's great. That a filled counts as a wall. Yes. Yep. But it discusses it a little bit in that mouse maze video. Because what the race is you start your mouse at the beginning, and then it has a certain amount of time to explore. Then it can go back to the beginning and start its real timer and finish. Super cool. Flood fill is a depth first search variant. Yes, that is correct. Feel like I'll paint myself into a corner. Depth first search can end up like that, but flood fill I think is a slightly safer version in that the way that it can backtrack is better. Ooh, and your gecko already saw the mouse video. Dang it! It's such a cool one. Even more curious about when you only have one chance. Yeah. I mean, that one, the guarantee is to follow the left wall rule or the right wall, whichever one. So I'm wondering if there's a good algorithm that's better than follow the right wall. Uh-oh. Okay, I'm gonna check my audio if it ever comes back up. Oh, come on. Watch now. Check my audio. Okay, back up. It's I lost power. Wait for internet to come back up. You're back alive. Okay. Shoot. Sorry about that. Okay, where were we? Mouse video. I'm more curious about when you have only one chance. Yeah. Oh, the flood fill pseudocode on Wikipedia is just a DFS. Is stream free? Yeah, no. Okay. Yep. So we're up to date. Hopefully people rejoin. We were having some good discussion there. In the meantime, where did I get to on this? Okay. 1, 2, 3, 4. Okay. Possibility number 2. Again, it doesn't have to be good. It just has to be good enough. So, go to project. Because I made some, well, what I think is happening is this. Maybe tokenizer definition. When we parse, we're going to pass in a length. I think we are reading. We probably should do this in VB project as well. This buffer may not have null termination, which sscanf is looking for. Which, while we're using fscanf, which is our bootstrap, but I think we have to copy all of our text. It makes me sad. Oh, no, let's just go with char star. Text equals new char len plus 1 third copy into text from text. Then everything else is the same. VV tokenizer definition parse into len. Instead of text, it's txt. Tokenizer definition. Okay, then the project. Delete text. Okay. Vietnam, welcome back. Welcome back. Good to see you. Let's see. Oh, I see a few of the people back in, so that's good. Yeah, we lost stream there for a minute. I power flickered here. I live in a pretty rural area. I have a UPS, so my computer doesn't die, but my internet goes down when the power goes off, so I had to wait for it all to come back up. Text buff dot. I don't remember size. The same thing in main is going to be a problem as well. Text buff dot size, because we are returning the size of bytes, not a number of characters. They may be the same, but they may not be the same if we use a UTF. Cam frozen. Cam frozen. All right, let's see here. Let me unplug and replug my camera, or is OBS just mad at me? Let's see. Okay, let me replug my camera. Okay, camera replugged. It dinged. Well, shoot. Huh. I'm not getting the blue light. Well, it looks like we're gonna go frozen cam for a bit. I'm not gonna. Yeah. Already wasted enough time. Shoot. Well, this is just a day of technology, isn't it? Yeah, camera's not coming back. I'll have to stop. I'll have to restart OBS or my computer or something. So we're pressing on. Pressing on. Did compilation finish? It did. Oh, it still crashes. Oh no. Oh. The third one. Okay. UV tokenizer definition.
He's over.
Okay. Let's see. Hey, Actions.
Owen, how much money do you have in here? I don't
Regex.
think so. Let's try again.
Name.
Now you lost.
Actions. Regex.
Where is it? I know where it is.
Name line actions XL regex new line white space discard. There's the white space rule. Actions discard regular expression for a comment in the line. And then it doesn't get any further than that. So it crashes on test.vtalk here. It did get the whole regex. So why does it not get token ID on the next time around? Hmm. Okay. Int total equals 0. Let's count total. If total equals 3, so we've got our 3 lines. Let's debug some. Log note offset. And that will be offset log note text plus offset. Maybe we're getting something weird. Modulus S, modulus. Well, let's see what inputs we're getting on the 4th line. Zero, 1, 2. Oh, it's 3, not 3. It's if total equals 2. It's our first time through this total is 0, not 1. Run it. Offset 39. Oh, interesting. So that's the comment. It doesn't make it to 3. Which is this one. When we finish this one, we're at 1, 2, 3. Okay. So it never gets there. So if we are here, and it's here, we don't get end of input. It gets all the way through regex, which should leave me with a pointer here. Like this is where the next loop should start at. So it should be valid, and that's a got 'em. In place back, and rules in place back. Okay. And placed. But it's that line right there, which probably means it's the constructor of the tokenizer rule where I made a mistake. Got 'em blows up before in placing or while in placing. This is where it's exploding. So if we go to the tokenizer rule, we get a buffer. We allocate room for a name. We copy that name. That name is stored. Create a new one. Copy, set, new one, copy, set. Is it because we're resizing? We could do the tokenizer rule. We could do a or VB tokenizer rule and operator equals to assign a const VB tokenizer rule other. We can also have a copy constructor just for funsies. Make a single function for all this junk. Which goes like this. Do we have it clear? We do not have it clear. Okay. That may also be a problem. Set name, actions, regex. Copy constructor. Set other.m name, other.m actions, other.m regex. And then the same thing for the assignment operator here. We tokenize the rule. Same as this one. VB tokenizer rule. We need one more helper, and that is void cleared. No, we don't need that, do we? We can do that. Could have been during resizing that we lost the they were getting some memory dangling. Then we can clear here if we need to. The structure should just take care of itself. I mean, we can even make this slightly better.
You know exactly what you're not supposed to do. You're just
Action equals no pointer. Just keep track of it. Just equals no pointer. Okay, we now have assignment and copy constructor. So hopefully it was during a vector resize when it didn't have those things properly implemented. It was copying memory, things were being cleaned up and deleted. And we're all better. Look at that. We have all of them now. And placed, token ID equals that. Got them and placed, looking for a rule, could not parse token, and we end. So that's all it's expected. Which means we can clean out the debugging messages. We no longer need to keep track of the total. Let's just keep looking for note. Clear log. Oh, no, that log stays. Total. We don't care about because we can always get that from the vector. All right. Yeah, OBS is causing me issues here. It also isn't updating the list of people viewing either. Still says the same list of people from when we went down. There we go. So our project, okay, and we're gonna do change to the log here. We're gonna indent that. And then the VB 1212. Okay. Oh yeah. We should add the turn this. I don't actually like that convention. There. We got 4 tokenizer rules, name, action, and pattern. Perfect. That was probably worse than it should have been. Okay. So then question. No, that's fine. Tokenizer definition. File now parsing. Bootstrapped with just scanf. Okay. Phew. Okay, so next time we do compilers, probably on Friday. We do game development without a game engine, Monday through Thursday. We will generate some output. We need a way to read a file in the thing that we generate. So that's probably just going to be like a literal copy of the text buffer with some extra features. Character reference is going to point to places in that file, and a string reference is going to reference multiple characters in that file. But those files generated will depend on whether you have ASCII, Latin 1, or UTF-8 selected. So that's probably next time. But we've got parts of the user interface coming. Hey, Savage Lord Severus. You were watching mice. Nice. I'm going to use the restroom real quick. Then we can chat maybe just a little longer about the mice. Okay, I'm back. So, how are the mice? Journal. I told. Star dot stack dump. Unit. Parsing tokenizer definition file. Boom. That's it. So let's go to source, word count, dash lines, start.hpp, start.cpp. We don't have any test code special files. We're at just under 900 lines of code. If we go to our journal, stream stats. This will be more complicated, but 3. She's in my room. Okay. Net lines added equals 893 minus 453. 440. We wrote 440 lines of code today without copying large amounts of files. Time on project, I'll calculate that later based on what I spliced together from the videos. I know it's been interrupted. Hours on project, again, we'll take that, blah, 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 lines per hour. No code was copied this time from another project. Good. Flood fill seems decent, but you need to know the maze size and location of the goal. You need to know how to identify the goal. Do you need to know where it is? That's a good question. I don't know. It's been a while since I've looked at flood fill. I haven't actually written a maze solver in a long time, and if you know the map, I always just used A star anyways, which also requires you to know the location of the goal and everything about the map maze. So yep, sounds good. All right, I think had a pretty good day's work. We've had a lot of good chat. Appreciate everybody in the chat contributing. It always makes it a lot more enjoyable than coding to myself, stream of consciousness talking. Yeah, Friday's variety day. We've done compiler a couple of times. We did tabletop game design last Friday. We were doing some world building for tabletop games I want to build. Then Monday through Thursday is game development with no game engine, which is a simple word deduction game. So join us for more streams. I stream 5 days a week. Try to be as consistent as I can. Fewer distraction to actual work output, lol. No, so on my Twitter, I actually posted the first month of streaming's numbers, right? And compared to what I've been doing at work for like the last 6 years, so depressing. Like I'm averaging between 30, 45, 60 lines of code per hour most days, right? Like 35 was one of my lowest days of output, and that's because instead of adding code, I was refactoring things that already existed. So I didn't add much code, which is why I want to measure churn instead of lines of code, but that's this whole separate discussion. So even with distractions and discussing other things, like this is way better than working at Amazon, where my average output was like 10 lines of code per month. Or no, not per month, but every 2 weeks. Just because it was so much crap on top of coding. Don't measure lines. Yes, but it's fast and easy. I did, so here, let me pop this up. In To Do, I did step out this morning while nobody was watching. The idea of measuring churn instead of raw lines of code. And here's roughly the process I'd have to code up. I'd probably throw it together in Python maybe with the only tricky part is processing the diff between the two commits. Stat doesn't quite give me what I want, and the raw diff would be uncomfortable to process, but doable. Uh, yes. So I've heard this story before. So I'll read it out loud for those who aren't in the. Yeah, my camera's frozen. My power went out, so I had to restart the stream. But OBS is like borked, so that the camera's not working. I replugged it in, but I think I have to reboot my computer. So you get a frozen camera view. Sorry. Anyways, so the story. Let me read it out so that people who aren't in the chat can hear it. He was at a company where they insisted on measuring progress by lines of code written, so in protest he did some refactoring and logged minus 2,000 lines of code. They stopped using that method after that day. I'm very good. Yes. These kinds of tricks are way easier when you're digital. So that story comes from the old days of Macintosh, early Macintosh. Let me see if I can find that Mac history. Minus 2,000 lines of code. Where is it? Can I find it? Folklore. Here we go. Where is it? So I'm in the right page, but I have to find the one where it's. Does this have a page have a search? It's not. It's too old. I know it's in this list. There we are. This one. Boom. Here you go. Here's the link. That's the original story. I've heard variations on it over the years, urban legend kinds of things, but I think this is the original one. Bill Atkinson. That was the name I was trying to remember. Yep. When corporate starts taking over, they measure things badly, and then everybody's productivity goes to crap. Okay. It's friend of a friend. Yep. Servers that powered off at 6 p.m. every day, or the 500-mile email. Yep, exactly. So this is, as far as I can tell, the original of that urban legend that keeps getting passed around. Bill Atkinson, early Macintosh developer. There's actually some really good stories on that folklore list. Like, just crank through it. Those old school coders, lots of stories, tons of fun. Most of them are pretty quick reads too. All right. So yeah, I think I may move to measuring churn eventually, but I have to write a script for that. And I wasn't going to do that on stream today. Maybe we'll do it next Friday. I'm in no hurry. I can always get the commit numbers and recompute things later. I was at the Foreign Office in the UK and someone tried to claim the 6 p.m. server story as their own. Yeah, I try to be pretty careful about that, where if I tell a story, I'll say a friend I know, or I did this, or I'll say I heard a story once that someone, and I'll try to be pretty clear about who actually does it. Sometimes I can't always dig up a source, but I'll try to be as honest as I can when I'm telling a story, whether I was involved or someone I actually know, or like you said, friend of a friend. Always gets a little fuzzier that way. Okay, so I think I'm going to wrap it up. Not quite as far as I wanted today, but that's okay. Interruptions, me being boneheaded, about sscan. Every time I have to use it, it's like, oh yeah, that's why. Oh yeah, there's that thing. You know, I don't actually read user input very much. And once we get this far enough along, we're going to completely replace all of fscan with our own code that we generated. So it'll be great. That actually is moving off your bootstrapped code onto generated code. That's always an adventure. But we are going to generate DFAs, and if Angered Gecko wants to rewrite it in NFA, then I would be thoroughly curious to see how the performance varies between the two. Or maybe I'll just do it myself. I will have the NFA. You generate the DFA from the NFA. So, yeah, we could do that. Anyway, we'll see. This is going to be a long project, so hopefully you folks join me for game development, join me for the Variety Day. I've got to go splice these two recordings together now so I can upload them. Yes. No, so part of the goal of this project is to, every time I think there's a reasonable place to look at performance, I'm going to implement 2 pound defined flags, one for one for the other. And I am going to debunk many performance myths and be like, hey, if we did it this way, like if we compute all the tokens into a vector and then hand them off, how does that compare to streaming the tokens as they're asked for? I mean, I know which one I think is going to be the more efficient, but I would like to measure how much. And if at the end of the day, it's like, you know, hey, you saved a millisecond. Well, who cares? Implement it the easier way then. Nobody cares about a millisecond. But if I can find some of them save me a larger percentage of time, then that will be, you know, informative. It'll tell me, hey, this file open method doesn't matter. I'm talking, camera's locked, I had a power outage, OBS is acting stupid. I think I have to reboot my computer to get the camera back up. But my skeleton has been known to pipe in. Yes, exactly. Thank you, Savage Lord Severus. Welcome to the chat, Dandy McGee. We're just about wrapping up here. I've got, you have good timing. It's rather strange. We've had a good time in chat today. Thought you were watching a YouTube video or something. Nope. I try not to. Although I did share one up above in the chat. We should probably raid somebody, huh? I need someone who's doing software and games. We got Tiberius, Big Boy Games Official, Odd Oculus, Line of Sight, Unreal C++. Ooh, he's using Unreal. He probably knows what he's doing. Oh, InfoSec plays the Illustrator. I'm thinking we go Unreal C++ guy. Let me see. Let's see if he's going live. He's still live. Okay. I hear you have visitors. Yes, my children are breaking in. My toddler is now able to push over my barrier. You have the same when she's awake. Yep. Yeah, streaming can get kind of loud around here sometimes. My sons are not the most controlled about where they start yelling. Okay, so let's go raid this guy. He looks like he's working on something interesting. Lots of Unreal, which I have not learned yet. So let's see here. Raid Odd Oculus. Did I spell it right? Thanks for joining. Hopefully you pop in more. Definitely appreciate all the chat. It definitely makes the stream go more. It's more fun than when I'm streaming consciousness to myself. Yeah. Good luck. Good luck finding your job. Take the weekend off. Get recovered, or drink, or whatever it is you do. Coping mechanism, and hopefully you get back on your feet pretty quick. All right, we're gonna go raiding. Raiding time.